Hello and welcome to another ASMR coding tutorial. I started this series last year, or earlier this year, but it's almost the end, of teaching you Python, and maybe some of you have this as a New Year's resolution, so in this case, wait a few days until you watch this, or start now. I went over basically everything you need to install Python. I do recommend to have some sort of Linux or Mac OS installation because the terminal stuff is just better. You can just use the Windows subsystem for Linux, but like I said, I went over all of that in the previous video. Feel free to check that out if you have questions about installing Python. Today we want to do something more than this. So last time we did this, just a print thing, and I believe you can execute this by just writing Python and test.py. Well, I guess not Python. It's like Python 3. Yeah. And then it prints what we wrote here. Today we will go over just the basics. And we'll just call this episode 1. Just variables types. You can use underscore, you can write it all in one. I like to use underscores. I don't think you're allowed to use dashes, so underscores is a safe bet. And then .py. Ignore this prompt. This is, I think, because of GitHub Copilot, which is automatically in here because I have the extension installed. Let's just pretend this is like an empty file. So let's take the code from last time. And this is print, which is a function. So that's something that you can reuse. That's predefined from Python. You can write your own functions, but this one is like one of the standard functions. And you can put any object, like any value, into this, and it will print it by default to the terminal. So if we type Python 3 episode 1 blah blah blah, so the name of our file, save it first, then it prints hello you there. And if we change this by, for example, putting a comma here and capitalizing this, save it and execute this command again, then you see that it changes. But what are we putting in here? You can also just print a line. You can also just put a number into print, and then it will just print a number as well, as if it looks basically the same as if we also would put this into quotes like the one above. You can't see a difference, but there is a difference if you work with it. For example, you can write 2 plus 3, and that will be 5. But if you write 2 plus 3 in quotes, then that will print 2 plus 3. What's the difference? So everything that you put between these quotes is a string. That's basically what you call words or text in many coding languages, strings. That's one of the basic data types of Python. For example, there's the type function, and if I apply this to test string, then the result will tell me this is of class. That's how you define specific types. Let's ignore this for now. But you see, it's a string. str is the short for string. So that's the data type of test string. That's also the data type of 2 plus 5, because the code doesn't care what's between those quote symbols. It's just all a string. So you see, this is string again. But if you instead use 2, for example, then you see that this is an int. And int is short for integer. And please don't ask me where this is coming from, but basically that's just a whole number. Is that what you call it? It's like a number without a decimal point. Like, I think they're called the natural numbers, maybe? No, natural numbers are only positive. Well, whatever. It's like everything from like -2 to 0. All of those are integers. We can test this. We can put -2 in here, and that's still an integer. Okay? That's for example 2. And if you put 2 plus 3, then it first calculates the response of this. It adds 2 and 3, and then it's just the same as if we would have 5 here. And then that's still an integer, of course. Any number without a decimal point will be an integer. Now, I guess the next obvious question would be, what if we have a decimal point? So let's test that. Print the type of 2.3, for example. And that's a float. And that's, I believe, a floating point number. Now, the point isn't floating, but let me write this first. So that's a float, which I believe means floating point number. Don't quote me on that. And it doesn't have to be 2.3. It could also be 2.1. As soon as you write the point, you say that this is supposed to be an entity of float. I think the floating has to do with how it's represented in memory and all this stuff, but you don't have to know this. Integers are numbers without decimals, like whole complete numbers, and floats are numbers with decimal points. And then, like I said, we have string, which is string, words or text within quotation marks. You can't write text without those quotation marks. If you just write words like this, then it says like, oh, this as a word is not defined. Because if you just write text, it assumes it's a function or like code, like type and print, which are functions. So you always have to put anything that's not code, you have to tell it, oh, this is just supposed to be text. You don't have to interpret this just print it as it is. Now you can still add things, I believe. Adding strings with a plus, if you have two strings, then they will just get added together to make it maybe a little bit more clear. Let's do apple plus banana, and that will write apple banana. Notice how it doesn't add a space in between. If you want to have a space, you need to put it either here or here, and if you do it on both, then of course there will be two spaces down there. So you have to be very precise with how you write things. Now that's the basics of types in Python, but this is all very, we call it hard-coded, where you just write everything in the line where you want it, but variables are where everything gets a little bit more exciting, at least at the start. So what you can do is you can define a bucket, so to say. So this is a string, right? But when I just write a string like this, it's there. But then if I want to use it down here, I have to write it again. And that's not very practical. But if I now say call this a string bucket, I can just do that. I can just say, okay, string bucket and then banana. And if I hover over this, you already see this is just like a little tip that my editor tells you, but you see this is a variable. I have defined a new variable. I said like, okay, string bucket will be, it calls it a literal, but this is now basically a string. So now if I go and say print the type of string bucket, then it says string. And notice that's the same as saying type of banana. If I run this code, then it prints 2 times string. This is the same. And actually, you can even check if string bucket equals banana, and that will output true. If I put apple here, it would be false. That's another type, and that's print type of true, and that's a boolean, short bool, and that's just, it can either be true or false, depending on if something is, well, true or false, if it is correct or incorrect, basically. Now we have the string bucket, and we can say, is string bucket equal to apple? And it's false. And then we can also print string bucket. And it will first tell us it's not equal to apple, and then it will print banana, and we don't have to write banana multiple times. Now you might think that's not very handy because string bucket is in fact longer than banana, but if we write this like that, and then we rewrite it down here, we could make a typo, right? This can't happen if we use the variable. But also, imagine we now want to change it. We only need to change it in one place and not in every place in our code. And if we want to make it something larger, then it automatically refers to this large text everywhere. And now this is way easier to write. But how do we know that this is a string? This is something that Python does a bit different from other coding languages. It can be intuitive, but you can see a lot of the things that are happening. So what I can also do is I can also save. I can also have a number bucket, right? And I save 2 in there. And then if I print the type of a number bucket, that will be an integer, because it's basically what the code does is instead of number bucket, it looks up, okay, what was number bucket defined as, and it finds, oh, number bucket is supposed to be 2. We put the 2 into the number bucket. Some coding languages also write something like this, I think, in R maybe. And it's like the 2 goes into the bucket, and then the bucket is basically the 2. So then if you write this, then what the code is doing, it's replacing this with 2, because it looks up, okay, number bucket is 2, and then you can put in the 2 here. In Python you write it with an equal sign, but it's always what's on the right side goes into the left side. Left side is the receiver, and then the right side is what is filled into this. So now it's an integer. How does it know? I guess what it does is it looks at this, and then it checks the type and puts it into the bucket. Like the bucket is now a number bucket. Maybe that's still fairly intuitive, but what you can also do now is you can reuse the bucket. You can take other text and put it into the same bucket. So if we print the contents of the string bucket, and then we say we take the string bucket again, and we say this now says apple. And we print the contents of the string buckets a second time. We reuse this, right? So first it says this is a small informational text, and it prints that. And now the new sentence was printed. If we leave out the first printing and just put first the first sentence and then the second sentence in there, then the first sentence is lost. What we could also do, though, is we can use the addition or appending of sentences by saying the new string bucket is supposed to be the old string bucket added with this new string. And now, I guess you can guess what this will print. Will look a bit ugly. It says this is a small informational text about bananas. Bananas are fruits. This now says apple. So we put both sentences together into the new bucket. And this is where the equal sign, you probably have to imagine something like this, right? String bucket will be what string bucket was before. So what the code does is it at first ignores what's on the left side and it computes this right side. It computes this new string and then it looks what's on the left side. What's on the left side of the equal and says, okay, everything on the right side, put it into this variable. And this could be a different variable, another string bucket, but it can also be the same. But what you can also do is you can reuse the bucket for something that's not a string. You can put 2 into the bucket, and if you print this, now it just says 2. I guess if we do this, then string bucket is a very silly name, but these are all silly names, so you could just call it bucket. And now if I rename both of these, but I don't rename this, then it complains that it doesn't know what string bucket is supposed to be, because we never defined it. If I try to run this now, then it says, oh, there's a name error. The name or variable string bucket is not defined. So you know that you also have to change this. And then the code can run again. Now, because this is very confusing, sometimes it's hard to read the code of people and know what they wanted to do, so what you often do is first you rename your variables to something that describes their purpose. You never want to do this, and that's why sometimes people say that this sort of variable typing system in Python is not very elegant. Other coding languages do something like this. You write that this bucket is supposed to be a string, and this you can write this in Python, but this is optional. You don't have to do this. But with this you say, oh, the bucket is a string, and this bucket is an integer bucket. There is optional type checking, as you can see. So now this says, oh, you use type annotations, that's this colon syntax, and recommends enabling type checking. Let's not do this for now. If we now try to put 2 into this, it still works. But there are tools, if you do this, that check if you accidentally put 2 into a string bucket, into a string variable, and then they warn you about it. So that's very practical for large amounts of code if you work with multiple people on the code, etc. But yeah, by default, just writing this is just something for you to remember, but it does not prevent reusing the same variable for a different type. I think there is a lot to talk about here. I could probably talk about this for hours and hours, but I think these are the basics, and I thought we can write a little bit of code to practice this, and the only thing I could come up with is writing a temperature converter. So we can use the input function to ask the user something in the terminal. example, we can ask what's the current temperature in Celsius. And if we run this, then you notice it prints the text, but then it doesn't go to the next input prompt. It stays like this, and it expects us to write something. For example, the current temperature is 2 degrees in Celsius, or I could write 2.0, and then the code ends. That's not very useful, but you see, if you hover over this, we have a prompt, and it returns, that's this syntax here, a string. So if we can save what we inputted, what we have put in the variable or bucket user input. And then we can print user has written, and then print the user input. So if we do this again and we write 2.0, then the next line will be user has written 2.0. Now I don't have to write a number currently. I could also write apple, and then user has written apple. So by default it makes everything into a string. So even if I write even if I write 2.0, that's a string, because it wraps it in a string, like the same way that 2 is a string and not a number. This input function basically puts quotation marks around everything that we write. Assume that we want to calculate what the current temperature is in Fahrenheit. Let's just Google Celsius to Fahrenheit, and this gives us the formula. 0 degrees Celsius is 0 Celsius times 9 divided by 5, 1.8 times 1.8 plus 32. In this case it's very simple because it's 0, but if we had 2 degrees, then it would be 2.1.8, which is 3.6, and then plus 32, which is 35.6. You can get semi-official from Wikipedia. So you can see that we get the temperature in Celsius, and then you have to do times 9 over 5, which is 1.8, and then plus 32, and then you get Fahrenheit. Or I guess the other direction, if you would have Fahrenheit, then you would have to do minus 32 and then times 5 over 9, but we do this direction now. So first we have to convert the number. We have to assume that the user puts a number in, and then we know the Celsius temperature. So what we do is we transform the variable. So we do float as a function around the user input, and that basically just float is like short for convert to float. This is also called typecasting in many coding languages. You write a type as a function, and then that's magically casting it into that type. And this will fail if we put banana in. We can test this if you want. So if I put 2.0, that's fine. If I put 2, that's also fine, because that will just transform it to 2.0. But if I put apple, it says it can convert a string to a float. Integer to string is very obvious. You just have to put a 0.0 at the end, so it's smart enough to know that. But string, it doesn't know that. It also obviously knows 2 will be converted to 2.0, because that's 2. And that can be converted to 2.0, but Apple, it doesn't know. So yeah, there's like various ways to avoid having this error. You can't show, like, you could make the user try again, etc., but we won't do that today. So this was a string. We can also write this here so we remember. This variable is a string. We cast it into a float that will then obviously be a float variable. And now for Fahrenheit temperature, we need to do the Celsius temperature times 9/5 and then minus 32. You can put brackets, but I believe it's smart enough to know that times comes before minus, I believe. But nevertheless, it starts from the left, which in this case is correct. But just to make sure, you can make brackets just the same as you do in math to say this should be evaluated first before you evaluate this additional part. So that's pretty much the same as in math. Also, if you've noticed, if I save, if I press like Ctrl S to save, it does some like automatic formatting. That's, I believe, part of this Prettier extension, but I'm not sure which extension this is. But it's very handy to have. And then we can print our result. First, let's just print the Fahrenheit temperature. So, what's the current temperature in Celsius? Let's put 2.0. I did it wrong. It has to be plus 32. Sorry if you've noticed before. I was just testing you. So, 2.0 degrees is 35.6 degrees Fahrenheit. That was indeed what Google also told us. So we did it correctly, but that's not very practical. So what we can also do is we can write the current temperature in Fahrenheit is, and now you have multiple options. You can either do is and then plus, but if we want to do plus, we can't write Fahrenheit temperature because that's a float, and you can't add a string and a float. It has to then be first cast to a string, and this with the space here and then a space and then a plus and then a string can get a bit unwieldy if you have, imagine you have multiple things and now maybe at the end you want to write, let's say we want to put this degree Fahrenheit at the end, then we would have to do another plus and then another string. And imagine we also want to do the user input and then write that this is in degrees Celsius. Now the line got so long that when I press save, it breaks it down into different lines, but it's still the current temperature plus user input plus Celsius in Fahrenheit is the new temperature and then Fahrenheit. Like, that is very annoying to type, but first let's see if it works. Let's say 2.0 and then it says the current temperature 2.0 degrees Celsius in Fahrenheit is 35.6 degrees Fahrenheit. At this point, Fahrenheit does not sound like a real word anymore. Something else that you can do is you can, wait, let me keep this part. Let's just make this as a comment and then we can create a new string, and that's called, I think it's literally called an F string. You write a little F before that, and now you can say the current temperature, and now you write curly brackets, and now you can say Celsius temperature. Close the curly brackets and just continue writing your string. And then you can do another curly bracket in the same string and say Fahrenheit temperature and then end the string. Let's just try this. And it's the same output. And notice how we didn't even have to write, oh, convert this to a string first. It automatically does that for you. So that's very handy. You can't forget this. And it's just, it reads, in my opinion, very nicely. And now it already fits on one line again. Almost, except for the print. So if we now had, for example, 13.2 degrees, that would be 55.76 degrees. And now you also see why we want variables or buckets, because depending on what the person writes, this formula will output something else. And we always want to put the input and the output in here. We want this to be, well, literally variable. So, without editing, this little tutorial took 1 hour. So, I apologize if this is very long. I apologize if I got a little bit excited while doing this. It got a little bit too loud. I will make sure to keep everything quiet, but it's very hard to speak extremely slow during this because there's just so much to say. But I do hope you learned something. I hope it was relaxing. I hope you fell asleep already if you wanted to, or you're just very relaxed and now a little bit smarter. But knowing you guys, you probably already know how to code and what it is anyways. I know I would. In this case, you probably just shouted at your screen a bit. I'm sorry. That's not the point of this. Anyway, as always, I hope you enjoyed this video. Thank you so much for watching as always. And I will see you in the next video. Bye.